So today we are going to cover section 3 from chapter 8. In this lesson, we're going to be able to show that a quadrilateral is a parallelogram. So basically, all of the theorems we learned yesterday, today we're going to flip them around, flip-flop them, and they're going to be the converse of what we learned yesterday. So we're going to be flipping everything. So here's our first theorem of this lesson. It's actually the 7th theorem of the chapter. Again, the number of the theorem is not important to us. What's going to be important is you're going to have to restate it in your proof. I don't want to see as a reason for your proof that it's theorem 8.7. You're going to have to restate the theorem as your reason. So in this theorem it states if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So yesterday it was backwards. It said if a quadrilateral is a parallelogram, then both pairs of opposite sides of it are congruent. Now it's backwards. They're giving us the congruency so we can prove that it's a parallelogram. This is our first way of proving that something is a parallelogram. And you're going to look that both pairs are congruent. Yes? Yesterday we were trying to prove, they started out by saying it's a parallelogram. If a quadrilateral is a parallelogram, then both sides would be congruent. So they were giving us all the properties of the parallelograms. Now we're going to use the properties to prove that it's a parallelogram. So we're going backwards. You do? Okay. All right. Next one, theorem 8.8. Again, numbers not important. Here we're going to say that if both pairs of opposite angles of the quadrilateral are congruent, then the quadrilateral is a parallelogram. So this is stating that angle B is congruent to angle D, and angle A is congruent to angle C. If both pairs are congruent, then our quadrilateral is a parallelogram. So this is our second way of proving that our quadrilateral is a parallelogram. Okay, theorem 8.9 states that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So in this case, the parallel marking and the congruent have to be on the same side. Okay, if I had something that looked like this, with the parallel here and the congruent here, this would not be enough information. Okay, so not enough info. This one would not work. The parallel indicator and the congruency mark have to be on the same pair. Next one, theorem 8.10. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So notice if we added another point in here, say point E, what you would state is that BE is equal to ED and that AE is equal to EC. Okay, then ABCD is a parallelogram. So that's basically what it's saying. So if the diagonals bisect each other, making two equal pieces, then the quadrilateral is a parallelogram. Question? Okay, so again, we're not memorizing this because if this were an SAT question, they're not going to ask you, give the theorem number. They're going to ask you to restate it. Okay? Because every theorem number is specific to the textbook. This is the 10th theorem in chapter 8 that we've encountered. Another textbook might go out of may have a different order. So this is why the numbers really don't matter. All right. Next slide. This is going to sum it all up. There were 5 properties of a parallelogram. So there's 5 ways to prove that the quadrilateral is a parallelogram. So here, you must show that both pairs of opposite sides are parallel. You would also have to show, another way would be to show both pairs of opposite sides are congruent. Another way would be to show only one pair, but it has to be parallel and congruent. Another way would be to show that both pairs of opposite angles are congruent. And the last way to show the diagonals bisect each other. So these are going to be 5 ways to prove a quadrilateral is a parallelogram. Next slide is the same thing, but we're going to have pictures. Next slide. Here it is, the same exact ways, except for now we've got some pictures. So this is what you're going to use when you write out your proofs. Again, we're not going to say theorem 8.7, 8.8, 8.9. We're going to give the statement. The only one that you could put down without having to restate what the definition is this one. You could actually put as your reason definition of a parallelogram, or state that both pairs of opposite sides are parallel. That would be the only one that you could shorten it. First example. Now we're going to actually think of this as 5 different questions. So we have to go through and state either the definition or the theorem that would enable us to deduce from the given information that the quadrilateral is a parallelogram. So for the first one, which theorem is this going to be? Restate it. Don't tell me the number. If BE equals ED and CE equals EA.
If the diagonals of a quadrilateral bisect each other, then there's a parallelogram.
Perfect. And that's what you would say. So you would say if diagonals bisect each other, then it's a parallelogram, and we'll just put a little picture. So that's number 1. So like we would show that this and this, let me do it in black. So this, 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 this. Okay, number 2, do it red. It says angle BAD, so this one right here, is congruent to DCB, this one up here, and angle ADC is congruent to CBA. Okay, Bella.
If both pairs of the opposite angles are congruent, it's a parallelogram.
Perfect. All right, I'll write it down here. So for number 2, if both pairs of opposite angles, OPP you can abbreviate and then do the little angle thing, are congruent, then we got a parallelogram. Here it is stating that BC is parallel to AD, and AB is parallel to DC. What would this reason be? For which definition or theorem? Michael?
Definition of parallelogram.
Good. This is the only one that you can shorten it, so you could put definition of parallelogram, or we can write it out and we can say if both pairs of opposite sides are parallel, then we got our parallelogram. or you can just put definition of parallelogram. That's the only one that we can shorten it. Yes? Yes. Okay, so now for number 4, do this one in green, and it's saying that BC is congruent or equal to AD, and AB is equal to DC. So this one is going to be what? Good. Okay, so for number 4, if both pairs of opposite sides are congruent, then it's a parallelogram. Good. One more. Perfect. I'll go back and do this one in black again. So this one is what she just said is if the same pair of opposite sides are congruent and parallel, then the figure is a parallelogram. Perfect. Okay, I'm going to add one slide to it, and we're going to do a proof. Here is my given parallelogram, A, B, C, D, and I'm going to be giving you that this is congruent and this side's parallel. So my given will be that AB is parallel to DC, and that AB is also congruent to DC. I want you to be able to prove to me that AD is congruent to BC. So we're trying to prove that this side and this side are congruent. So here's how we're going to do it. We're going to have our statements, and we're going to have our reasons. And I know we haven't done a proof in a while. Always start out with your given. So AB parallel DC and AB congruent to DC. So this is my given. Next, what could we say? Any ideas? Yes.
That ABCD is a parallelogram.
Perfect. ABCD is a parallelogram. Okay, so he says ABCD is a parallelogram. What's my reason, or what's your reason?
Because if one pair of opposite sides are congruent and parallel, then the figure is a parallelogram.
Perfect. So if the same pair or one pair, so we could say same, pair of opposite sides are both congruent and parallel, then the figure is a parallelogram. Step 3. What can we conclude? Jason?
Segment AB is congruent to segment BC.
By what?
Because each pair of opposite sides of a parallelogram are
Okay, so what we're going to say here is not what we just learned today, but what we learned the other day. So if it's a parallelogram now, then opposite sides are congruent. Good? So there'll be easy proofs if you know your properties. If you don't know the properties, the proofs are going to be challenging. And again, there's going to be 19 different things you're going to need to memorize. Okay? Right now, we've only covered the parallelograms. We're going to be covering squares, rectangles, rhombuses, kites, trapezoids, That's why there's going to be 19 of them. Okay, so again, I've got a nice review sheet in the module if you want to start using it, or if you want to organize it with whatever format you want to do. But we're going to slowly build on these, and again, continue to review them, so that way next week you're not going to be overwhelmed come Thursday. Okay, so your homework is practice B for 8-3. Should be on Canvas. You can go ahead and start it. If you get stuck on a question, let me know and I will help you. Any question?